Hello everyone, my name is Andrew Ackerman, and today I'm going to be going through problem 8-8, part D, from Elements of Chemical Reaction Engineering, the 4th edition. So in this question, we are looking at the same PFR that is used in question 8-8, part A. And this time, we're going to be taking into account the pressure drop in the PFR. So for this question, we are given this equation here, where P is the pressure, W is the weight of the catalyst, alpha is the particle size, T is the temperature, P is the pressure, and X is the conversion. So for this question, we're given a choice of two particle sizes. So for this example, I'm going to be using this first alpha value here. And basically what this question is asking us to do is to plot the temperature, conversion, and pressure across the length of the reactor. So we are given the reaction A goes to B plus C, and the first thing that we're going to do is take our given equation here and we're going to find epsilon. And to do that, we're going to use equation 3-35. And solving that out, we find that epsilon is equal to 1. So we then take that, we plug that into our given equation, and this is what we are left with, and I'm going to call that equation 1. Next, from table 3-5, we're going to take this equation here, and then from E4-6.9, we have this equation here, and we're going to sub this equation into this one in order to obtain this equation 2 here, where X is the weight of the catalyst, X is the conversion, W is the weight of the catalyst, K is the rate constant, X is conversion, T is temperature, P is pressure, and V is the velocity. And now what we're going to do is we're going to take equations 1 and 2 and we're going to input them into polymath, as you can see here. So here we have our equation 1 and our equation 2 and then equation 1. And so from part A, we then have this here, which is the equation for the temperature. Then we know from the question that our initial pressure is going to be 10 atm, and we're going to put that in pascals here. And then, so this is the alpha value that we have chosen to use. Then V is the velocity, which is given to us as 20. The temperature, the initial temperature is given as 450. And then these are the parameters that we have set up for our first equation here. And then we also are given the equation for the rate constant here. So then essentially what we're going to do is we are going to run this and let it run as a table and a report, and they both pop up, and then using the table you can then graph separately the conversion across the length of the reactor, and you get this linear graph. Next, we were asked to graph the temperature across the length of the reactor, and we also get a similar linear graph here. And lastly, we were asked to graph the pressure across the length of the reactor, and this looks more like a step function as it goes across the length of the reactor. And that is all.